So in the early days of Impulse, we were spending our time developing a ball drop technology, industry leaders, being first at the race of turning a tool on. Focused all of our energy into that, had an existing product line that was utilizing Acme style connections known to the motor industry, and we developed a product line, starts being used, and then we started to see customers do a shift. Normally a vibration tool was around 600 meters, maybe 2,000 feet behind the bit, relatively low torque environment. With being able to turn the second tool on at any given time you wanted, we started to see customers run 2 or even 3 tools, and the tools naturally migrated up the string closer to the build section. And what we didn't see coming was how much increased torque was there. So very quickly, customers, whether they were using Impulse technology or they were using dual tool or multiple tool systems even from competitors, started to see connection failures happening once the tools were ran 2,000 meters or maybe 6,000 feet behind the bit. So we started to try to understand what's happening, and really we turned to the world of connections. So what I have right here to show you today is how the evolution worked. Years ago, this is a double shoulder connection, but it's based off an old API connection that's decades old, and large taper, not a lot of real estate to work in if you want to put something inside this connection. So naturally, some decades ago, they migrated towards an Acme connection in the motor world, gave you more real estate. Speed things up to 2015-16, we need to have even more real estate when we're trying to design the inside of a tool. And more importantly, we need to have more strength. So these two connections right here, from a torque perspective and a strength perspective, are essentially the same. But if you think about designing and putting things inside a connection and how much real estate room you have, you can obviously see that you have much more room to work with here than here. One of the biggest things that happened as we migrated from a single shoulder Acme style connection to a double shoulder is not only the increase in torque, but it was a limit in failure. So in the old connections, because the nose didn't shoulder up against anything or bottom out, as you applied more and more torque, the connection would want to keep going. And common failures, you'd see a box that was split. It might get to the point where if the box split, this would continue to turn and the box would actually pass up past the shoulder of the tool. In the double shoulder world, the tool shoulders at the top and the bottom. So as you try to apply over torque, the connection has nowhere to go. It's housed between its two shoulders. One of the challenges that's always present when we're developing downhole tools is the rigidness of the tool. So if you have a tool that's really only laying out in the lateral, it's not that big of a deal. But as we started to migrate up the string with our multiple tool systems, now we're rotating and going through the build section, we have fairly extreme bending forces on the tool. Single shoulder connections don't necessarily handle cyclical bending loading as well as a double shoulder connection does. So not only do we get the increased torque, we get increased real estate for what we want to put inside the tool, but the tool inherently handles cyclical loading, bending loading that we see as we transition through build sections or turn sections into wellbore.